All right, let's dive deep into space-time. That whole space and time thing we always hear about in sci-fi movies. Like, can you actually break this space-time continuum? What does that even mean? We're going to be checking out this article from WatchMojo.com called "What If the Space-Time Continuum is Broken?" And it gets into some pretty cool concepts, like time dilation. Imagine, right, you're traveling near the speed of light for like 10 years. Feels like a few months to you, but bam, back on Earth 20 years have gone by. So time dilation shows just how weird time can be, but does it actually break space-time?
Well, it definitely makes you think, but time dilation doesn't actually break space-time. It's kind of important to remember that space-time isn't like a real physical fabric. It's more like a mathematical model,
Yeah.
something physicists use to understand how things move and work together in the universe.
Oh, so it's not like some kind of sheet out there that can, like, rip or something. Yeah.
Exactly. It's helpful to think of space-time like a map. It shows the journey of a particle, its world line, from beginning to end. And just like you can fold or crumple a map, massive objects like stars and planets actually warp space-time. And that warping is what we experience as gravity.
So a massive object, like, creates a dent in this cosmic map.
Precisely. And the more massive the object, the bigger the warp. Which leads us to black holes, the ultimate space-time benders.
So
right?
black holes, those mysterious things that gobble up everything around them. Could they be the key to breaking space-time?
Well, they definitely push space-time to the limit. At the center of a black hole, you have a singularity, a point of infinite density where space-time is so warped that nothing, not even light, can escape.
And that's where things get really interesting, right? Because we don't actually know what happens inside a black hole. It's like the laws of physics as we know them just kind of stop working.
Exactly. And it brings up this puzzling question called the black hole information paradox. We know energy can't be destroyed, so where does all the stuff that falls into a black hole go? Some physicists think that information might be encoded on the event horizon, that's the boundary of the black hole. Others think that the information is preserved inside, but in a way we don't understand yet. And get this, some scientists are actually trying to make miniature black holes in labs to study them.
Mini black holes. Now, that sounds kind of risky, don't you think? But speaking of black holes, did you hear about those two supermassive ones that are on a collision course? In the quasar PKS 1302-102, it's been going off for like 3.3 billion years, and they're expected to collide in about 100,000 years.
It's a cosmic event on a scale we can hardly imagine. Astronomers are definitely excited to study the gravitational waves that'll be released when those two giants collide.
It's like a front row seat to a space-time showdown. But, okay, so if black holes aren't technically breaking space-time, what about wormholes? Those theoretical tunnels through space-time, shortcuts across the universe.
Wormholes are fascinating, and physics doesn't say they can't exist, but we haven't actually seen any yet. Some theories even suggest that black holes themselves could be wormholes, with white holes as their exits.
White holes? What are those?
So picture a white hole as the opposite of a black hole. Instead of sucking everything in, it spews matter and energy out. It's a very theoretical idea, and we haven't found any proof they exist. But even if wormholes are real, they're probably super unstable and maybe even radioactive, making them basically impossible to travel through.
So much for using a wormhole to zip across the galaxy. But here's a wild thought. What if wormholes are constantly popping in and out of existence all around us, but they're just super tiny and disappear quickly?
If that's true, they'd be way too small and fleeting for us to notice. But it does raise the question, could these wormholes be temporarily breaking and then fixing space-time as they blink in and out? It's a question that really pushes the limits of what we understand.
It really makes you wonder if space-time is a lot more dynamic than we think, huh? Okay, let's switch gears a bit and talk about something that's not just theoretical anymore. Time crystals.
Time crystals. They're a great example of something we thought was impossible, but now scientists have actually made them.
So what exactly are they? They sound kind of magical.
Think of a regular crystal. Its structure repeats in space, right? Well, time crystals have a structure that repeats in time. And they do it forever without using any energy.
Wait, so they're like perpetual motion machines, but on a tiny scale.
In a way, yeah. Time crystals are our first look into a whole new type of matter called non-equilibrium matter. They actually break a fundamental law of physics called time translation symmetry, which suggests that the future might not be as set in stone as we think.
Whoa, that's huge. They're breaking the laws of physics.
Yeah.
Makes you wonder what else is out there just waiting to be discovered.
Yeah.
So we've talked about all these ways space-time could like rip or tear, but what would that actually look like? Would things start glitching out like in the movies?
Yeah.
Would the laws of physics just stop working?
That's the big question, isn't it? And it's one that's been on the minds of physicists and sci-fi writers forever. We might not have all the answers, but there are some pretty wild theories out there.
Okay, hit me with those mind-blowing theories.
Well, one place to start is quantum mechanics. The weird world of tiny particles where the normal rules of physics don't really apply.
Quantum mechanics where particles can be in multiple places at once and cats are both alive and dead.
Exactly. And some physicists think that these quantum quirks could hold clues about spacetime itself, like the concept of quantum foam, for example.
Quantum foam. Sounds kind of bubbly.
It's not literally foam, of course, but it helps us visualize spacetime at its smallest level. Imagine spacetime not as a smooth fabric, but as this chaotic sea of quantum energy, with tiny bubbles of spacetime constantly popping in and out of existence.
So at the quantum level, space-time is more like a constantly shifting, chaotic froth.
Exactly. And within this quantum foam, there might be spots where spacetime gets incredibly distorted, like so intensely curved that it could actually tear.
Hold on, so these quantum fluctuations could be creating tiny rips in the fabric of reality.
That's the idea. While these tears would be incredibly small and wouldn't last long, they could have huge implications for how we understand the universe. Some theories even suggest that these tears might be connected to the birth of black holes, or even the Big Bang.
Whoa, we're talking about events that shape the entire cosmos. What would happen if we actually encountered one of these quantum tears? Would we get sucked into another dimension? Would reality just cease to exist?
Those are great questions. But our current understanding of physics can't really answer those for sure.
Yeah.
But it's definitely fun to think about the possibilities.
Totally. Okay, so we've got quantum foam creating tiny rips in space-time. What else is out there that could break it?
Another possibility is higher dimensions. We experience the universe in 3 dimensions of space and 1 of time, but some theories suggest there might be more dimensions that we just can't perceive.
Hidden dimensions, like a secret universe tucked away right under our noses. It sounds like something straight out of a science fiction novel.
It does, doesn't it? But these higher dimensions don't have to be separate universes. They could be curled up and compacted, existing at every point in our 3-dimensional space, but at scales so tiny we can't detect them. Think of it like this. Imagine a garden hose from a distance. It looks like a 1-dimensional line, but up close you can see it has a 2nd dimension, curled up in a circle. These higher dimensions could be similar, just curled up way tighter.
Okay, I'm starting to get it. So these hidden dimensions are like tiny curled up spaces existing everywhere but too small for us to see.
Precisely. And some physicists think these extra dimensions could be influencing the forces of nature, including gravity. Now imagine if something were to disrupt these higher dimensions, causing them to unfold or become unstable.
What would happen then? Would reality start glitching out like in a bad video game?
It's definitely possible. Messing with higher dimensions could have catastrophic consequences for spacetime, maybe causing tears, warps, or even a complete collapse. But again, this is all theoretical.
So we have quantum foam creating tiny rips and possibly unstable higher dimensions causing chaos. Are there any other contenders for breaking spacetime?
There's one more theory we should touch on, and it involves energy itself. We know energy can't be created or destroyed, only transformed from one form to another. But what if there's some weird form of energy out there, something we haven't discovered yet that could mess with the balance of space-time?
Weird energy. That sounds like something out of a superhero comic. What kind of energy are we talking about?
It's hard to say for sure. We're kind of in the realm of speculation here. But some physicists have proposed the existence of negative energy or phantom energy. These are forms of energy with really strange properties that could completely change our understanding of physics.
So instead of pulling things together like gravity, this phantom energy would push everything apart.
That's the idea. And if there were enough of this exotic energy, it could create areas of space-time where the laws of physics as we know them just don't work anymore.
So like parts of the universe where gravity works in reverse or time flows backward? That's wild. It makes you realize how much we still don't know about the universe and reality itself.
It really is humbling, isn't it? And it's important to remember that these are just theoretical possibilities. They show us that our knowledge of space-time is still incomplete. There might be forces and things out there that we haven't even begun to imagine, things that could push space-time to its breaking point.
It's both exciting and a little bit scary to think about. But let's say one of these space-time breakers actually exists. What would that mean for us? Would it be like those apocalyptic sci-fi movies where everything falls apart?
All right, welcome back to our final part of our space-time deep dive. We've talked about black holes, wormholes, time crystals, even quantum foam, all that crazy stuff. But what I really want to know is, what would a broken space-time actually mean? Like, for the universe and for us? Would it be like in the movies where everything starts glitching out? Would the laws of physics just go haywire? It's a great question, and honestly, there's no easy answer. But based on what we've been talking about, we can explore some possibilities. Let's start with a small tear in space-time, maybe from those quantum fluctuations we were talking about, or a tiny wormhole popping up. What do you think we would see?
Hmm. I'm imagining like a weird shimmering distortion, kind of like a heat wave, but way stranger. Could we even see it? Could we walk through it?
That's a cool visual. It might be invisible, or we might detect it as some weird blips in our measurements of space and time. As for walking through it, well, that's where things get really interesting.
Okay, I'm hooked. What could happen?
Some physicists think that going through a space-time tear could transport you to another point in space-time, like a different spot in the universe or even a parallel universe. Imagine a shortcut through reality itself.
Whoa, teleportation or a trip to another dimension? That's insane. But wouldn't it cause all sorts of paradoxes, like meeting your past self or changing history?
Exactly. That's what makes the idea of space-time tears so fascinating and mind-boggling. It messes with our whole understanding of cause and effect, time, free will, even the nature of reality itself.
So a tiny tear could mean teleportation or alternate realities. What about a much bigger tear, like a huge rupture? What could that do?
Now we're talking cosmic level events with potentially catastrophic consequences. A giant tear in space-time could mess up the flow of energy and matter, leading to stars collapsing, new black holes forming, maybe even entire galaxies unraveling.
It sounds like the whole universe could just unzip, awe-inspiring and terrifying at the same time. But would a space-time rupture always mean the end of everything?
Not necessarily. The universe is vast and amazingly resilient. Even with a major tear, there's a chance space-time could repair itself over time, like a wound healing.
So even if space-time breaks, there's hope that the universe could fix itself. But how could it heal such a massive tear? What could even do that?
It's a great question, and it shows just how much we still don't understand about space-time. Some theories suggest that the quantum nature of space-time itself might allow it to heal, maybe by creating virtual particles that stitch the tear back together. But again, this is all very theoretical, and we're really pushing the limits of what we know.
It's amazing to think that something as fundamental as space-time could be so strong and yet so fragile.
Hmm.
It really makes you feel small, like we're just tiny specks in this vast, ever-changing universe.
It does, doesn't it? And while we may never fully understand space-time or what would happen if it broke, exploring these questions is what's important. It helps us understand the universe and our place in it, and reminds us that there's always more to learn and discover.
This deep dive has been incredible. We've explored the depths of space-time, from its weird properties to how it could break and what that might mean for us.
And as we wrap up, I think we're left with a really profound question. If the very fabric of reality can bend, warp, and maybe even break, what does that tell us about existence itself? It's a question that'll keep physicists, philosophers, and sci-fi fans thinking for a long time.
That's a perfect way to put it. We've learned so much about space-time, but we've also uncovered even more questions.
Exactly. And even if we never have all the answers, the journey of trying to find them is what matters. Keep looking up at the stars, keep asking questions, and keep exploring the universe. Who knows what amazing discoveries are waiting out there?
Well said. And that wraps up our deep dive into space-time. Thanks for joining us. Until next time, keep exploring the wonders of the cosmos.